Hello. Do you want to know something about binomial theorem? Today we'll be discussing about finding out the general term of a binomial theorem. Now, when we have the sum or a difference of two terms, then we call it a binomial. And if suppose we talk about past 2 and past 3, these are what even children can tell us. But if we want to find out the value of a binomial which is raised to a natural number power such that this natural number power is greater than 3, then that is what we are interested in. Now, if we want to find out some specific term, then finding out the general term is what is going to help us. In this lecture, I will be telling you people how to find out the coefficient of a term which contains a variable of a specific power. And when that is the case, then what is the coefficient of that term? Further, if it is a sum or a difference with another binomial, then how is it that you will be able to find out the coefficient of that variable raised to that specific power? So if you want to know all of this, I hope you should stay from the beginning till the end of this lecture so that you can understand every speck of it. And if there is any doubt which is withstanding, I also give you a second explanation which helps you out. But before that, after telling you the formula, I will be throwing a challenge to you people, which is about a sum. I'll give you a little time. You can elongate the period of time, give it a good try. And after that, I will be discussing the sum from the beginning till the end so that anywhere you have a doubt, all of that gets cleared. Now, this is for the children who are from international baccalaureate because this is a sum of the type of questions that are asked there, as this topic is also there in international GCSE or in the IC board or in the CBSE board. So all of the children who are pursuing class 11 and class 12, especially the ones who are in grade 11 or class 11, are the ones for whom this video is perfectly of the type that you're really searching for. So children, to begin with, I will quickly tell you that if suppose we have a binomial, let's say we have some x plus a, and if it is raised to a natural number power n, then how is it that you will be able to find out the general term? The general term normally is given by TR plus 1. For this, you can better look up the shorts which I have given you people just before this, where I have discussed this formula in detail, right? Also with an example. So children, if you have TR plus 1, which is the R plus 1th term in this binomial, it is a term which is somewhere in between and it is known as the general term. And that is then given by NCR, the first term x, which is raised to the power, the difference of the numbers in the superfix and the suffix. Now, what is the superfix? The superfix is the number which is above, and what is the suffix? It's a number which is below, all right? And the second term, which is a, it is raised to the power, the number which is there in the suffix, that is this. Okay, so this is how the general term looks like. Now, we're going to apply this concept in trying to understand how actually, if we have a sum of this type, we're going to deal it. So here comes your challenge. I challenge you people to try this sum out. I'll give you people a little time for trial, and after that, I will be discussing the sum. But you will feel really successful if you're able to do the sum in this time period that I have allotted for you people. So at this time, I'll give you people just 10 seconds in which, if suppose you're not able to even start and try and think, then fine. Then you can look up the solution. Otherwise, you can pause the lecture and give it a longer try. Complete the sum before I explain the sum. Okay? So your time starts now. I hope you're seated at a place where there is no disturbance and you are not taking the help of anybody, even if it is an electronic gadget or probably some software which actually makes things easy. Because till the time you don't face the ire and the fire, how will the shine come in you? Having said that, let's quickly now look up how exactly we're going to do this. Now, I'm thinking this, that you people must have learned the formula that just came before you. You've looked up this short and also understood the example that was given there. And further, you have also tried this out. Okay, now let's have a look at this sum. This sum says find the coefficient of x cubed in the expansion of this that has been given you. Now here you get to see that first there is a binomial whose power is 5. Next we have another binomial whose power is 3, right? And you've got to find out the coefficient of x cubed. So let's get ahead with the first binomial that we have at hand, and then we will come over to the second binomial. So here children, if you talk about this x cube minus 1 upon 2x, which is raised to the power 5, right? In this, we can find out the general term by the formula that we just discussed. That is, if you talk about some tr plus 1, which is the general term, then that will be equal to 5cr, the first term x cube, which will be raised to the power 5 minus r, and the second term minus 1 upon 2x, which is raised to the power the number which is there in the suffix, that is r, right? So this will be the general term. Now, if you're interested in finding out what is going to be the coefficient, then that actually is the number which is multiplied with any term which will contain x cube, right? So let's first try and actually find this coefficient out, then you'll be able to understand that better. Now, as you know that 5cr is going to come to be a natural number. So that's a constant which will be multiplied with the term containing x cube. Fine. Then we will have some power of x which will come, right? And further then, if we talk about the other numbers which are associated, it will be minus 1 upon 2, which is going to be raised to the power r. And if we talk about the power of x, then that will be 3 times of 5 minus r, right? And further, this is multiplied with x raised to the power minus r. That's because if you talk about 1 upon a, you can write it to be a raised to the power minus 1. So this x came over to the numerator, had its power to be minus 1. And then I'm sure you people must be knowing this, that if we talk about a raised to the power m, which is raised to the power n, then the power rule of exponents gives us a raised to the power m into n, right? Now children, further continuing this, we now further are going to simplify this. So further, this is going to become equal to 5cr minus 1 upon 2, which is raised to the power r, and then we will calculate the power of x here. That becomes equal to 15 minus 3r and minus r. So thus we can write this as 5cr minus 1 upon 2, which is raised to the power r, and further that gets multiplied with x raised to the power 15 minus 4r, right? Now we want this as 3. So we will write 15 minus 4r, which is the power of x, to be equal to 3. So you will say here, but 15 minus 4r is to be equal to 3. Now further we will solve this. So as such, we will now have 15 minus 3, which will become equal to 4r, just by transposing the terms to the correct sides, the terms with r on one side and the terms with the constants on the other. So 15 minus 3 is going to be given by 12, right? And that is going to be equal to 4r. Now further, 4 is going to cancel 12 3 times. As such, we will get the value of r to be equal to how much? 3, right? So we have the value of r to be equal to 3. That means if here in place of r we substitute 3, we should be able to get to the coefficient to be this, right? So let's find that out. So we will have this thus as t3 plus 1. That means in the fourth term this is going to happen. And what is the coefficient? The coefficient is all the numbers which are multiplied with this. So it will become 5c3 minus 1 upon 2, which is raised to the power the number which is r, that is 3 here. And further we know that this is going to get calculated 3, but even then we will calculate it and double check it. So 15 minus 4 times of 3, which is the value of r, has been kept. So for the children, this comes out to what? This comes out to 5c3, which can be written as factorial 5, which is divided by a factorial of 5 minus 3 times of factorial 3, and further it is multiplied with minus 1 upon 2, right, which is raised to the power 3, and x raised to the power 15 minus 12, which will again become equal to 3. Thus, we have come over to the correct term, right? We just require to calculate this number, and we will not be done, because you remember this was with another binomial, right? And that other binomial was subtracted from this binomial. Okay, so further when we calculate this, we can write this factorial to be 5 to be 5 into 4, which is further multiplied with factorial 3, and then further in the denominator 5 minus 3 will become equal to factorial 2, and then further is multiplied with factorial 3. I'm sure you're able to see happily that factorial 3 will get cancelled, and factorial 2 is actually 2. So 2 gets cancelled with 4 2 times. So 5 into 2 becomes equal to 10. So as such here, we will have 10 for the binomial coefficient. Further, this is minus into minus into minus will make it minus, and 2 cube is going to make it 8, right? At the moment, we will just write it to be 2 cube till the time further simplification happens, right? So for the children here, we have this to be multiplied with minus. So as such, the final sign is going to be minus. Now this can be written to be 2, which is multiplied with 2 square, and further that is multiplied with x cube. As such here, if you try finding out what the final value of the coefficient or the number multiplied with the term containing x cube is going to be, so it will become equal to minus 5, because this 2 is going to be cancelled with the 2 which is there with 10. So 2 5s is 10, right? So you will have 5 upon 4, right, with a minus sign, which is multiplied with x cube. That will become the coefficient of the term containing x cube. Now for the children, next, now we come over to the second term, rather binomial. That's 3 upon x plus xy raised to the power 3, and try and understand this. So we have here, for the second binomial, 3 upon x plus xy. So we have 3 upon x plus, I forgot that again, plus xy, which is whole raised to the power 3. So we have plus xy, and it is raised to the power 3. Now let's try and understand where exactly are we going to get the term which contains x cube. Yeah, tell me, which term? Somebody is telling me the fourth term. Third term. Well, I'll tell you the answer is none. I'll show you how. If you talk about the first term, it will be upon x cube. That means 3 cube upon x cube. If you talk about the second term, it will be 3a square b type of a term. So it will be 3 into 1 upon x square. Excuse me. 3 into 3 square upon x square into xy. Right? The next term again is going to be 3ab square. So again, there will be a term with y. Right? That means except x cube, there's also going to be a term which contains y. Right? And now when we talk about the third term, we will actually have here this to be xy whole raised to the power 3. So a term which contains x raised to the power 3 is actually the third one, right? So here we can say that in this term containing x cube is going to be the third term. And what exactly is the third term? It will be is the fourth term. That means the last term, xy whole raised to the power 3. And that, children, will become equal to x cube y cube. Right? Okay. Abhinav, you have a doubt. What is the doubt? You want to know what is the cube formula? Well, I'll tell you. If you have some a plus b and you want to find out the cube of this, then for this we have a direct formula. Why not use it, and why use the binomial theorem? So this comes to a cube, and then write with reducing power of the first term. So you have 3a square b plus 3 ab square, and finally you have plus b cube. Now, if we talk about the first term, in that we will not be able to get the term with x cube, right? As such, we'll be talking about the second term, right? So let's look it up what happens. So further here, if suppose, because Abhinav wants to know, so I'll tell him further in detail that further what is this going to become. So the first term here is going to become equal to 3 upon x whole raised to the power 3. To that is going to be added 3 times of 3 upon x whose whole square we have, and further that gets multiplied with the second term raised to the power 1, that is xy, that's it. And then to this is going to be attached here the third term, which is 3 times of 3 upon x, which will come with power 1, and xy, which will come with power 2, and the final term is xy, which is raised to the power 3. So if you see here, in the first term, you will get the power of x to be how much? It will be x raised to the power minus 3, right? Because it will be 1 upon x cube, right? Now, if you talk about this term, in this term, we will get 1 upon x square and 1x above. As such, you will get the term of the type of 1 upon x. Now, if you talk about the next one here, we have x, which is going to come as the final term with x, because in the numerator the power of x will be 2 and in the denominator the power of x will be 1. Finally, you will get a term with x cube, as this is xy whole cube, so that will become x cube y cube, right? We are not interested in y, so as such we'll remove this y. So thus we are interested about the third term, right? So now children, next what we're going to do is we will now be talking about coefficient of term containing x cube, and that children is the first one that we had minus 5 upon 4x cube, right? And from that children is going to be subtracted this term that we just found out in the second binomial. So it will be minus, and we write this complete term, that is minus x cube y cube, right? And further here we get to see that we can actually take this x cube to be common outside. So further what do we get? We get minus 5 upon 4, and except that we get minus y cube. Now just tell me, if you talk about this second term, is it not a term which contains a variable? It contains a variable, as such we will not be able to take this, right? Because we should directly be able to get only constants, right? We don't expect any variables. Because when we want to find out the coefficient, it is the number which is multiplied with the term which contains x cube, and here as there is another variable, so as such this term cannot be taken. Till the time I did not do up to here, I couldn't actually make you people correctly understand that this term is not going to be taken, because you would have thought that this has x cube, why not take this? The reason we can't take this is because it is multiplied with y cube, so it simply doesn't become a number. We should be knowing the value of y, only then this will become a number, right? And that is the reason why we will avoid this second one, and we will say that the second binomial when expanded does not have a term containing x cube. That means when it's a term with x cube, it should contain only the variable which is x cube and no other variable, right? So as such, finally, now we can write the answer, which is to this question is minus 5 upon 4, right? And that is because the second expansion gave you a term which had x cube, but along with that y cube was also multiplied, so that does not become a proper number which you can just add or subtract to this earlier number. As such, only minus 5 upon 4 is going to be considered. That is because here, one thing more, Here thus, the only term which contains x cube will be what? Therefore, only term containing x cube as the variable, children, will be what? Will be minus 5 upon 4 times of x cube, that term which we found out in the early expansion. So I will now quickly explain this to you. If you have any doubt anywhere, then all of that is going to be clear. So children, in this question, we had this, that we've got to find out the coefficient of x cube in the expansion of this minus this binomial. Now here, we actually are using up this formula that if we talk about the expansion of x plus a, which is raised to the power n, then the general term is tr plus 1. Then we have the general term to be ncr x raised to the power n minus r, which is the difference of the numbers in the superfix and the suffix. Further, the second term a is raised to the power the number which is there in the suffix, that is r. Now further here, children, in order to get to a specific power of x, we actually have to talk about this general term. So let's talk about this general term in the first binomial. So in the first binomial, we use all of these variables as they were, and we get this to be the general term. Now further, we solve this out and we get to the different powers of x. Use the rules of indices, right? There's another rule of indices which has got applied here, and I'll write that for you. That is, if you talk about some a raised to the power m, which is divided by a raised to the power n, then by the quotient rule, children, we have this to be a raised to the power m minus n, which has got applied here, right? And further, we have the final power of x to be found out. But this power of x, which is here, should actually be 3 because we are talking about such a term which contains x cube. So as such, we'll be talking about 15 minus 4r to be equal to 3. Okay. Then all these numbers which are multiplied with it are actually the coefficient of this term, right? So further here, we calculate this binomial coefficient by keeping the value of r after calculation of this. When we take this 4r to the other side, we have 50 minus 3, which becomes equal to 12. 4 cancels 12 3 times, as such r becomes equal to 3. Now we keep this in place of r wherever it was. So it becomes 5c3 minus 1 upon 2 raised to the power 3 times of x raised to the power. We calculate this for final satisfaction, and this actually is going to give us x cube, right? So further here, we keep that value, and this comes to factorial 5, which is divided by factorial of 5 minus 3 times of factorial of 3, the number in the suffix. Now when we calculate this, this comes to 5 into 4 multiplied by factorial 3. Factorial 3 gets cancelled. 2 gets cancelled with 4 2 times. 5 into 2 is 10, right? But there is also this minus 1 upon 2 cube, which can be written as 2 into 2 square, right? Why minus? Because when you multiply minus with minus, it will give you plus. Again, when you multiply it with minus, because the power is 3, it will give you minus, right? So finally, we have this minus sign, and then further, we have 5 upon 4, which is going to be multiplied with x cubed. So what is the coefficient? The coefficient thus is this number, which is minus 5 upon 4 for the first term. Now, I showed you the second term is actually not of use. Rather, the second binomial from which we will get the term with x cube, okay? So if you talk about this term, then here we get to see that there is no clear term which has x cube. Now, explaining orally is fine, but most of the children understand when it is written before them. That is why I wrote the formula of a plus b whole cube, wrote it for this specific case, and showed you that there is a term which has x cube, and how it is not of our use is what I showed you later, right? So here I use this formula to expand, and we got to all the different terms. Now, the last term was the one which had x cube, but along with it, it also had y cube, and that's the reason why it was rejected. Now, if we talk about the terms containing x cube, and if we add up those, because here we have a difference of both of these binomials, so obviously you will have this term, and then you will have minus times the other term. So as such here, we wrote the first term minus times the other term. Now, in the other term, when you take x cubed to be common outside, you are left out with minus 5 upon 4. However, you have minus y cubed inside, which is a variable raised to some power. Obviously, unless and until you know the value of y, you will not be able to find out what y cube is. As such, the term containing x cube is only minus 5 upon 4 x cube, right? And thus, this is the only term which will give you actually the coefficient of the term containing x cube, right? So minus 5 upon 4 thus becomes the final answer. So is this clear with everybody? For sure. Now I think if there are questions in finding out the coefficient of a specific term in a binomial, you will be able to do it with ease. So now your task is to immediately practice this in your copies, make yourselves comfortable in this, and after that you can try out other sums. Otherwise, if you want this exact page, then I will share the link in the description. You can click on it and then you will get this exact page where I've given you this, so that will help you in copying and understanding more properly. Further, there'll also be a homework. A similar sort of a question will be given to you, so make sure you do it too and make yourself perfect in this topic. If you want to know more, you can click another link which is there in the description or in the first pinned comment, where I'll give you the link if you want to fast track your journey, because learning just one sum every day or probably 3-4 sums in a week is not what is going to get you 90% marks or probably 100% marks. For that, you require regular mentoring. So if you want that, if you want me to perfect every topic of yours which is going to come in your International Baccalaureate AAHL examination, so click on the link, give me a few details so that I can actually customize your journey to be able to make you 100% successful and make you actually a mathematics ambassador. Bye, children. Have a nice time. Have a nice journey in mathematics. It is very interesting, not intriguing, and I'll prove that to you the moment you meet me. Bye.